In this question, we are given a triangle with vertices at A, B, and C, and the task is to find the circumcenter. Now, in this case, we are actually doing a problem that we did in the previous video. The distinction is in the previous video, A, B, and C were of the same form, but they were concrete points. So in other words, B and C in particular were specific points with actual numbers as coordinates. In this case, obviously A is the origin, so I have to go with 0, 0. But for B and C, I'm going with generalized coordinates. This raises the level of difficulty of the problem a little bit, but hopefully with those of you who are really strong with your pure, you will really benefit from working through this problem. I will say if this is a bit challenging, then feel free to take a look at the previous video and then come back to this video, and hopefully that would help. Okay, so for those of you who are joining us for the first time, I should say circumcenter is essentially the center of a circle, and the circle is actually a special circle for which the triangle with these vertices is actually inscribed in the circle. So in other words, the sides of the triangles are actually chords, okay? And to be able to figure out the center of that circle, we're going to use the fact that perpendicular bisectors of chords intersect at the center. In other words, the perpendicular bisector of each chord in any circle will always pass through the center of that circle, okay? So let's look at a diagram to get a sense of what's really happening. So A is at the origin, we see that. C is on the x-axis, the distance gamma along, we see that. It's on the x-axis and the distance is gamma along. And B, I've said, is in the first quadrant, so this is the first quadrant. And there's B, a distance alpha across and beta up. Okay, now we want the point P, where the perpendicular bisectors to the three sides actually meet. So we can see that the green line is the perpendicular bisector of the side AB, the blue line is the perpendicular bisector of the side BC, and the brown line is the perpendicular bisector of the side AC. Now, since these lines are perpendicular bisectors, they bisect. So in other words, they split whichever chord they are intersecting into two equal parts, and they make an angle of 90 degrees, right? And you can see that for this side too, this chord is split into two equal parts, and the line makes an angle of 90 degrees. And lastly, for this side, this chord is split into two equal parts, and this line makes an angle of 90 degrees, okay? So we need to figure out the equations of these three lines and then solve them simultaneously. But of course, to be able to work out the equations of these three lines, we need at least one point on the line. And so in each one of these cases, the point to go with is actually the midpoint of the respective side, okay? Right, now we need the coordinate of the midpoint. And there's a really nice formula on the syllabus where you can figure out the coordinate of the midpoint by basically adding up the corresponding x coordinates of the 2 points for which you're trying to figure out the midpoint and then dividing by 2. So 0 plus alpha divided by 2 is just half alpha. And likewise, you do the same for y. 0 plus beta divided by 2 is just a half beta. So that gives us this coordinate, the midpoint of AB. And we do the same for B and C. So alpha plus gamma is alpha plus gamma, but then we have to halve it. So we get a half alpha gamma. And beta plus 0 is beta. We halve it, we get a half beta. And lastly, 0 plus gamma is gamma. And then we halve it to get a half gamma. And 0 plus 0 is 0. And we halve it to get 0. So we've figured out our three midpoints. So we can start to now figure out the equations of these lines. Now, the easiest line to write down the equation for is line L3. Let's see what the equation will be. Well, the equation will be x equals a half gamma. This should be completely expected because this line L3 is actually a vertical line. It has to be vertical because it's perpendicular to the base AC, and AC is actually on the x-axis, and the x-axis is horizontal. So this has to be vertical. So it's vertical, and it passes through a half gamma, which means x equals a half gamma, and y can be any number at all, which is why you actually have a vertical line, because y can be any number at all. Okay. So we have the equation of this line. Now let's figure out the equation of line L1. We need to figure out the gradient of L1, and that's not easy. The sensible way of doing it would be to figure out the gradient of the segment AB, and then use the fact that this line L1 is perpendicular to the segment AB. Okay, so the gradient of AB is going to be change in y over change in x. Well, my y2 is beta, my y1 is 0, so the numerator is beta minus 0. My x2 is alpha, my x1 is 0, so the denominator is alpha minus 0, which simplifies to give me beta minus alpha. Then we use the perpendicular gradient property, which means if I want the gradient of my line L1, which is M1, I need to take this, I need to flip it, in other words, do 1 over, and then stick a minus in front. And this is what I've done to get the gradient of M1. And so this must be the equation of L1. And all we have to do is figure out the value for C1. Now, we can find this out provided we know a point on the line L1, and we do. We know that the point half alpha, half beta, which is the midpoint to AB, must lie on L1. So actually, I can replace y with a half beta and x with a half alpha to be able to get this equation. So we see our y is a half beta, our x is a half alpha, and now we can rearrange this to figure out C1. So all I'm going to do is I'm going to take this term here, which is minus alpha over beta times by half alpha, and take it to the left-hand side. And we get this. So we get C equals a half beta plus this term, which was earlier negative. Now it's on the other side, so it's positive. And so we just need to simplify that. So I will multiply alpha by alpha to get alpha squared, and I will multiply beta by 2 because 2 is in the denominator to get 2 beta. And now to be able to combine this, I need a common denominator. And I have a 2 here, I have a 2 here, but I have a beta here. I don't have a beta here. So I can multiply top and bottom by beta. So the top will become beta squared, and the bottom will become 2 beta. And now that I have a common denominator, I can actually combine the numerators. And so I will get beta squared plus alpha squared on top and divided by 2 beta on the bottom, obviously. But beta squared plus alpha squared is the same as alpha squared plus beta squared because order of addition doesn't matter. So we actually have our C1, which we can put back into our equation, and this is the equation of our line. So you see, you will have calculated lots of equations of lines, but this one is looking a little bit more challenging because we're dealing with generalized coordinates. But this is exactly the sort of practice one would need if one is to really get those high grades on the A-level, okay? So now that we've got the line L1, let's figure out the equation of the line L2. And I'm going to go a little bit faster, and I've got some information summarized here. So L2, if you remember, would be the line which is the perpendicular bisector of the side BC. So I need the coordinates of B and C to be able to figure out the gradient of BC. So let's see that. So the gradient of BC, the segment, is going to be y2 minus y1 over x2 minus x1. This is my x2, y2. This is my x1, y1. So y2 is 0, y1 is beta, so numerator 0 minus beta. x2 is gamma, x1 is alpha, so the denominator is gamma minus alpha, and obviously this simplifies to just give me minus beta over gamma minus alpha, and from this we can figure out the gradient of the line L2, which is perpendicular to the segment BC. So basically we will take this and we will flip it and we will stick a negative in front, okay? And when we do that, this negative would die and we will end up with this expression here. And once we have the gradient, we know what the equation of the line is going to look like. It's going to be y equals m, which is our gradient now, right? M2 in particular is our gradient, x plus c. So it's the c I'm calling C2, which is the y-intercept of this line. And we have to figure that out. To be able to figure that out, we would use the fact that the midpoint of B and C, in other words, this point here, lies on the line, okay? So using the fact that this coordinate satisfies the line, I'm going to replace that y by the y value of the coordinate, which is a half beta. And then I'm going to replace that x with the x value of this midpoint coordinate, which is a half alpha plus gamma, all in brackets. So that's there. And now we have to solve this equation for C2. So in other words, I'm just going to take this messy term and take it to the left-hand side, right? Which gives me this. And I have to simplify this so that I have something nice and workable in the end. So let's work on that. So what I want to do is think of this as a fraction and think of this term here as a fraction, and the two fractions are being multiplied. So when we multiply fractions, we just multiply the numerators. So I'm going to multiply gamma minus alpha by gamma plus alpha, which is what I have here. And then I'm going to multiply the two denominators. I'm going to multiply my beta by the 2, which gives me 2 beta. Okay, so this entire term simplifies to give me this term, right? And let's see what we can do next. The next thing to notice would be to look at these two brackets and recognize they're literally the same with the opposite signs. Okay, in other words, we have the difference of two squares here. But when I expand this, I'm certainly just going to get this term squared minus this term squared, because the cross term is going to cancel. And so this is exactly what I have. This is the first thing squared, the gamma squared, and this is the alpha squared. Okay, so now this is a lot nicer than what we had to begin with here. So what we're going to now do is make this even nicer for us, and we want a common denominator for both of these, which means I have to multiply this by beta top and bottom. So when I do that, I get a beta squared on top and I get a 2 beta on bottom. And now I have a common denominator, which means I can combine the numerators. So I'm just going to say it's the first numerator subtracted by the second numerator, which gives me my new numerator. And then I have a common denominator. Okay, so now lastly, I can take this negative and actually expand into the bracket. So the negative would give me negative gamma squared, but then the negative with that negative would give me a positive alpha squared. So this is essentially our C2 term, which means we can basically say, since we have our C2, we can write down the equation of the line L2. So again, looks a little bit challenging, but really for the top grades, one needs to be able to handle these sort of things. Okay, so now we're at the final home stretch. We just need to solve the equations of line L1, L2, and L3 simultaneously. And so a nice way of doing it would be to realize that actually line 3 has the simplest equation. So let's solve simultaneous equations in pairs such that we use line 3 to help us do that. Okay, so I'm just going to substitute the equation 3 into equation 1, which means the x value there I'm going to replace by a half gamma. So I've done that there. And then we treat this as gamma over 2 and essentially multiply it with this fraction. So I'm going to get alpha times by gamma, which is this thing here. This negative here remains, so I've got that there. And finally, the beta times by the 2 would give me the 2 beta. And then I've done nothing to that term. I've just kept it here. But now the interesting thing is this already has a common denominator, so I can actually combine the numerators. So what we need to do is combine this with this. And because that has a negative, I can basically do this quantity take away this quantity, which is exactly what I have there. Okay, and obviously common denominator, so I can just have 2 beta. So actually we've got a solution for y, and we know what the x was. So what we can say is the point x equals a half gamma and y equals alpha squared plus beta squared minus alpha gamma all over 2b is actually the point of intersection of line L1 and L3. And so we now solve equations 3 and 2 simultaneously. In other words, find the intersection of the line L3 and L2. And we do the same. We substitute equation 3 into equation 2. So I take this x and I replace it by a half gamma, right? Which will give me this expression here. And we'll play the same game, which is to multiply these two fractions. So let's see what we'll get. Essentially, I'm going to have gamma minus alpha multiplied by gamma, which will give me this. And I'll have beta multiplied by 2, which will give me this. And then the second fraction, I'm literally going to copy as it is. Okay. And I would like to observe at this stage that we again have 2 beta in both of the denominators, which means we've got a common denominator. So we can just add the numerators directly. So I'm going to have gamma minus alpha all multiplied by gamma added to this thing. And when I do that, I actually get this. So gamma minus alpha multiplied by gamma added to alpha squared plus beta squared minus gamma squared. And obviously all of it is over 2 beta. So we simplify that, we expand the bracket, so gamma times gamma will give me gamma squared, and minus alpha times gamma will give me minus alpha gamma, and the rest of the numerator will just remain. But then we notice that we've got a positive gamma squared and we've got a negative gamma squared. So these two gammas are going to cancel, which means my numerator is now simpler. So I'll just have alpha squared, which is there. I'll have the beta squared, which is there. And then the minus alpha gamma term I can actually write at the end slightly more neatly, and obviously the denominators are unchanged. So we actually have our solution for y. And again, if you notice, we've found the exact same point. We've found that x has to be a half gamma, and y has to be alpha squared plus beta squared minus alpha gamma all over 2 beta as the point of intersection for line L2 and L3. And so since we have that lines L1 and L3 intersect at this point, and lines L2 and L3 intersect at this point, in other words, all of the 3 lines L1, L2, and L3 must intersect at this point, and therefore this point must be our circumcenter. Okay, so we've found our circumcenter. Now, if you've stuck through with this video and you've followed the details of what's happened, then take a bow, really well done, and thank you for watching. And obviously, if you found this useful, then consider subscribing.